Levi used the box plot below to say half the class walked more than 30 laps at the walkathon. Levi also knows that his class has more than 20 students. Do you agree with him? Explain your reasoning. If you do not agree with him, what statement could he say about those that walked more than 30 laps? So I noticed that we've got a box plot here. I'm going to label the different parts. So this is the minimum. This is Q1. Here's the median, Q3, and then the maximum. And I know that the median shows me where half the data is. So half the data is below the median and half the data is above the median. So he said half the class walked more than 30 laps. Well, Q3 is at 30. So this isn't telling me that half the class worked more than 30 laps. This is saying 25% of the class walked more than 30 laps. So 25% of the class walked more than 30 laps. Or he could change the part where it says 30 laps. He could change it to the median, which is maybe 27. Or he could say half the class walked more than 27 laps. Levi wants to describe the portion of students who walked between 20 and 30 laps. What statement could he say? So between 20 and 30, that's the middle 50% of the data. Because we've got 25% here between the minimum and the Q1. We've got 25% here between Q3 and the maximum. So that means there's 50% of the data in between Q1 and Q3. So 50% of the students walked between 20 and 30 laps. How could you alter a single data point and not change the graph? How could you change only one data value and only move the median to the right? So let's see, we want to alter a single data point and not change the graph. So if we changed one number in between, so for example, in between, the minimum's probably what, 4? In between 4 and 20. So if we change one number in between 4 and 20 to another number between 4 and 20, it would not change the graph. And then it says, how could you change one data value and only move the median to the right? So if we wanted to move the median to the right, we would want to make the median, bigger, which would mean, let's see, we'd have to make the median bigger, we'd have to take one of the smaller data points and move it into the bigger data points. So to make the median bigger, we would have to, so we would take a number less than 27 and make it greater. Than 27. Can you determine how many students are in Levi's class? No. No. A box plot only tells us about percentages of the data. Oh, you can't see that. Okay. Create a box plot for the test score data below. Label the median, minimum, maximum Q1 and Q3. Then determine the interquartile range. So the first thing I need to do is put these in order. So let's see, the smallest I've got is 70. Then 72. 75. 76. Now I'm into 80s. So I've got 80, 82, 85, 90, and 93. I'm going to add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's all my data. First I'm going to find, so we've got minimum, Q1, median, Q3, maximum. So the minimum I know is 70. The maximum I know is 93. Now to find the median, I'm going to find the one in the middle, so I'm going to cross off. So 80 is the median. To find Q1, I need to take the lower half, not including the median. So, and then I'm left with these two. So 72 to 75, right in the middle of that is 73.5. So Q1 is 73.5. This one I cross off there, and I'm left with 85 to 90. Halfway in between that is 87.5. So that's Q3. So my box plot, first I'm going to draw a number line so that it's scaled correctly. So I'll go from 70 all the way to 100. And let's see, that's 80, it's 30. So here is 80, 90, 100. So there's 75, 85, 95. Okay, so my box plot, I've got the scale. Now I can do it. The median's at 80. The Q1 is at 73.5, so that's right about there. Q3 is at 87.5. So here's my box. And then the whiskers, the max is 93. And the minimum is 70. Now to find the interquartile range, we need to do Q3 minus Q1, which equals 87.5 minus 73.5, which is 87.5 minus 73.5, 14. So the IQR equals 14. Which of the points below is a solution to this equation? More than one point may be a solution. Explain how you figured it out. So in order to do that, I need to test all of these points in that equation. So I'm going to plug in 1 for x and 2 for y. 4 times 1 plus 3 times 2 equals 10. I got to check to make sure it works. 4 plus 6 equals 10. That's good, so that one is true. 4 times 4 plus 3 times 2 equals 10. 16 plus 6 equals 10. I know that's not going to work because that's 22. So that's not true. 4 times 7 plus 3 times 6 equal, oh shoot, it's minus. Well, that's problematic. Then this one does not work. That's minus, that'd be -2, so that's wrong. That one's wrong. This one would be 16 minus 6, which is true. So that one's right. This is minus, so this is 28 minus 18. That is true. 10 equals 10. And then 4 times 4 minus 3 times negative 3 equals 10, 16. This is plus 9. That's not going to be true. That's 25. So B and C are the correct answers there. Find the equation of the line that passes through these 2 points. So first thing I need to do is fill out y equals mx plus b. I'm going to find the slope first. So I'm going to draw a quick sketch. 2, 6 would be right about there. 5, negative 3 would be down here. So if I draw a slope triangle between them, this is 2, 6, this is 5, negative 3. To go from 2 to 5, we went over 3. And to go from negative 3 up to positive 6, we went up, 3 to get to 0, and then plus 6 would be 9. So the slope is the change in y over the change in x, which is 9 over 3, which equals 3. So I know that the slope is 3. In order to find the y-intercept, I'm going to plug these points in. So I'll plug in 6 for y and 2 for x. So 6 for y equals 3 for the slope times 2 for x plus b. 6 equals 6 plus b. That tells me that b is going to be 0. So the equation of the line is just y equals 3x. Find the equation of a line with a slope of 3/4 that passes through this point. So again, I'm going to plug in. So I'm going to plug in 6 for y. So 6 equals 3/4 is the slope times 6 for x plus b. So that gives me 6 equals 3/4 times 6 is 18/4 plus b. Now I'm going to take the whole thing and I'm going to multiply by 4 to cross out this fraction. So 6 times 4 is 24, which equals 18 plus 4b. Then I subtract 18, and I get 6 equals 4b, divide by 4. b equals 6/4, which simplifies to 3/2, which is 1.5. So the equation of the line is y equals 3/4 x plus 1.5. Graph the following lines. X equals negative 3. So if x is always negative 3, then that's going to be right here. It's going to be a line, straight line at x equals negative 3. I'm going to label that A. B, I'm going to skip and come back to that in a second. C, negative 3x plus 0, so it starts at the origin. You go minus 3 and over to the right 1. Here's my line. So this is line, oh no, that's not B, that's C. Line D is y equals 7. So I'm going to go up to 7 for y and draw a horizontal line. Now to do B, I need to put this in y equals mx plus b form. The first thing I notice is that all of these numbers are divisible by 2. So I'm going to divide both sides of the equation by 2. So I get x minus 2y equals 8. Then I'm going to subtract x from both sides. Negative 2y equals 8 minus x. Divide by negative 2. And I get y equals 8 divided by negative 2 is negative 4. Negative x divided by negative 2 is positive 1/2 x. So in y equals mx plus b form, it's y equals 1/2 x minus 4. So I'm going to start at negative 4, go up 1 and over 2. And it's right here. And this is line B.